This problem is just a quick review of reflection, refraction, and the Brewster angle. The Brewster angle is the special angle that makes it so reflected light is completely polarized. And I'll post a link real quick to the video where we first discussed the Brewster angle. So we're given the incident angle here of 35 degrees. And in part A, we're asked to just sketch the incident ray, the reflected ray, and the refracted ray reasonably accurately. So I want to show a ray that looks like it's something like 35 degrees coming into this point. And then my reflected ray should have exactly the same angle. So we'll try to do a reasonable job of that. The assumption here is that this is air, and air has an index of refraction of about 1. This is a transition from a faster medium to a slower medium, and that means my refraction bends toward the normal line. And I'll just label that as theta r. So that's part A. And then in part B, we want the angle of refraction. So we use Snell's law for this. In N1, that's the index of refraction in the air, is about 1. Our incident angle was 35 degrees. N2, 1.5. Our angle of refraction is theta r. So we divide by 1.5 and then invert the sine function to solve for theta r. And when I run the numbers on this, I get 22.5 degrees for the refracted angle. Again, just qualitatively checking our work, you should verify the refracted angle is going to be a smaller angle than the incident angle because this was a fast to slow transition. Finally, we're asked to compute the incident angle at which the reflected ray would be perfectly polarized by reflection. And again, you might want to refer to the link I posted at the beginning of the video to find out where this was derived. But the angle at which the reflection is perfectly polarized is the incident angle that gives you a 90-degree angle between the reflection and the refraction. And that's called the Brewster angle, and it turned out to be the inverse tangent of N2 over N1. So we're really just plugging in 1.5 for N2, 1 for N1, and I get a Brewster angle of about 56.3 degrees. So that incident angle that gives you perfectly polarized light out of the reflection, that's a pretty shallow angle, the 56.3 degrees measured with respect to the normal. My reflection would look something like this. My refraction, something like this. And the key to finding that Brewster angle is that the angle between the reflection and the refraction is 90 degrees. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.